Here in this video, we discuss about the line angle formula of organic compound. Formula of organic compound. This type of formula also we call the skeletal formula. Now, how do we read this kind of formula, or how do we read or write this type of formula? Let's try to understand that. So, say for example, one simplest hydrocarbon methane. This is the condensed formula for methane, right? We cannot do much about this because there is only one carbon. We cannot represent this by using the line angle formula. So methane formula is CH4. It is simple enough. Now, whenever we go with the two carbon like CS3 and CS3, this is what we call is ethane. This is the condensed formula. This can also be represented other way by this type of line here, and this is the line angle formula. So how to read here is, this is the end point. We represent the carbon, and since you have your hydrogen, the three hydrogens on each end, the hydrogens are hiding. In skeletal formula or line angle formula, the hydrogen attached to carbon are hiding, with that we don't show those. So we know that this is the carbon, and there is one bond, that means three hydrogen here that is hiding. Likewise, this is also the carbon with one bond, so three other bond is bonded to hydrogen, those are hiding. So this is also CS3. So ethane we can just simply represent by drawing the line like this. And how to read this? This carbon is CS3, this is CS3. Now the other molecule says CS3, CS2, CS3, that is propane. And this type of this condensed formula we can represent it by zigzag line like this. So this terminal point is CS3. In the middle here, this carbon, you have two bond, that means two hydrogen, those are hiding there. Likewise, this is other carbon, you have three hydrogens here. This is carbon, you have three hydrogens here. So basically this is CS3, CS2, CS3. In line angle formula we represent like this, or you also can represent like this. These are actually the conformations, so you can draw either way, this way or this way. Likewise, with the four carbon CS3, CS2, CS2, CS3, this is butane. And in line angle formula, 1 2 3 4, 1 2 3 4 carbon, this terminal point is CS3, this is CS2, CS2, CS3. So again, remember that this is carbon, one bond we show here, three hydrogens are missing or hiding, CS3. This one, you have two bond, this is carbon with two bond, two hydrogens are hiding. So this is CS2, this one is CS2, this one is CS3. Basically, you can write this way or this way. You can write either way. So that is what we call butane. Similarly, for pentane, whenever you have five carbon, CS3, CS2, 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 CS3, five carbon, we can represent 1 2 3 4 5. So this is how we can simply represent by drawing the line like that. It's the line angle formula, zigzag line. Okay. And hexane, so this is your pentane, and hexane we can draw 1 2 1 2 3 4 5, one more 6. So this is the hexane line angle formula, 1 2 3 4 5, 2 3 4 5 6 7. So this is heptane, and so on and so forth. That is how we can draw the line angle formula for the um, alkane, the straight chain alkane. Now let us talk a little bit about the isomers of alkane here. Isomers of alkane. Isomers, and again we are talking about the constitutional isomer. Isomers of alkane. So for CS4, this there is no other way to, only one carbon, there is no other way of writing that. So CS4, there is no constitutional isomers there. But whenever you have CS3, two carbon, there is not much we can do with this. So there is also no you cannot write in different way for this one. Likewise, whenever you have CS3, CS2, CS3, three carbon chain, there is only one way that we can represent as a straight chain. You cannot make any branch of this one here. But whenever you have four carbon, like see 1, 2, 3, 4 carbon, this is a straight chain, which we call as the butane. This is the straight chain butane. This is the structural formula. You can write that as a condensed formula like this: butane, line angle formula, 1, 2, 3, 4 carbon chain. Okay, but this four, whenever you have this four carbon, there is other way. As you know that carbon can form the branch structure also. So with the four carbon, so this is the formula here, C4H10, that is the molecular formula for this butane, 4 carbon and 10 hydrogen. With the four carbon, you also can form like this, like 1, 2, 3 carbon in the chain and 1 carbon as a branch. Now if you complete the hydrogens here, 1, 2, 3, 4, just put the hydrogen, remaining hydrogen, 1, 2, 3, 1 hydrogen should be here, 1, 2, 3, 4. Again, remember, alkane, saturated hydrocarbon, also single bond, 1, 2, 3, 4, all are hydrogen here. So this is the other structure for same molecular formula, C4H10. Now if we write the condensed formula for this is CS3, you have your CH, you have CS3, and here is also CS3. So this is how you get one as the branch. So this is again molecular formula same, but the way they are connected is different in these two, right? Their connectivity is different. So if you wanted to write the line angle formula, 1, 2, 3, and here is branch. So the name that we will be discussing later on, IUPAC name of this will be 2-methyl propane. Propane, also you can call that as isobutane. Isobutane, and that is a common name. Okay, this is normal butane, N-butane. This one is isobutane. These two are the compounds containing same number of carbon, same molecular formula, but the way they are connected is different. That is what we call constitutional isomer. Constitutional isomers, or how they are connected, is different. So 4 carbon chain in the chain, and here is 3 carbon in the chain, one as a branch there. Okay, so these are the two constitutional isomers of butane. Similarly, if you go with the bigger hydrocarbon, say for example C5H12, that means pentane. So 5 carbon chain, 1, 2, 3, 4, 5, all are hydrogen. That is what is the structural formula. You can write the condensed formula for this also, right? CS3, CS2, 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 CS3, that is the condensed formula. And line angle formula 1, 2, 3, 4, and 5, that is the line angle formula for pentane. Now this 5 carbon you can arrange in different ways. So 1, 2, 3, 4 carbon in the chain and one branch like this, the condensed. So if you put all remaining as the hydrogen there, you can fulfill that. So again, you can put all hydrogen there. So the condensed formula will look like CS3, CH, this will be as a branch. So one branch there, CS2, CS3, that is the condensed formula. So the name will be 2-methyl butane, and the name we will be talking about that later on this chapter also. The line angle formula, 4 carbon chain, one as a branch. By the way, the same structure, you can have the branch in different way, like say 1, 2, 3, 4, the branch here. But if you look at these two structures, they are exactly same. So they are just the conformations only, but this is the same structures there. Okay, so you either you have the branch here or here. It will be, if you flip that, it will be the same. So this is the another um, constitutional isomer. There is other way of writing this 5 carbon, right? So 1, 2, 3 carbon in the chain and 2 carbon as the branch. Still 5 carbon. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So all are hydrogen, all hydrogen. So this is, if you look at the condensed formula, so this will go like CS3, C, CS3, CS3, CS3. That is how this will go. So this will be 2,2-dimethyl propane is the IUPAC name. The carbon number 2 has 2 methyl group, therefore 2,2-dimethyl propane. And the line angle formula for this will be 1, 2, 3 carbon in the chain and 2 methyl group on the same carbon here. This is what we also call the neopentane. Neopentane. So this is another constitutional isomer. So if you look at the pentane, you have one, these two, either this or this will be the same, 2 and 3 constitutional isomer for this pentane, okay, C5H12, and there are 2 constitutional isomer for butane. Now if you can still go with the hexane, it will be larger the number of hydrocarbon chain, larger will be the number of constitutional isomers. So the constitutional isomer means, one more time, constitutional isomer, they will have what? Same molecular formula, but they will have what? Different connectivity, therefore different name, and name will be different, and their struct name different, and structure also will be different. That is what we call constitutional isomers. So the alkanes or saturated hydrocarbon are well popular for this kind of constitutional isomers. Okay, all right, so that is it for on this one. So this is what we call constitutional, and I would suggest you to draw the constitutional isomers for C6H14 or hexane. How many constitutional isomers are possible? Please try to practice on this one. Thank you.